So let's go back to learning about text operations and some more advanced forms of text operations, manipulating text and strings. So we'll go back to the MyPersonQuery file. So we'll just go File, Open, and go back to MyPersonQuery. And MyPersonQuery should read title and the expression involving title and first name and last name as the expression column, full name from person.person. So I think having a little title column, extra column there on the far left has served its purpose. Let's get rid of that. Now, as you know, many people may have conjoined last names. It's actually two names put together to form a last name. Let's actually search for those using wildcards. Last name, like, single quote, wildcard, space, wildcard, quote. In other words, any name which has something, a space, and a something. And there they are. Dermot Jr., Van Eaton, you see what I mean. Now, just to demonstrate this next operation, let's just put last name on the far left there. And you know what, our line's getting a little bit long, so let's just put last name on its own line there. And you can see my point. Okay, so let's just say there is a business requirement to have the last chunk or component of a conjoined last name on its own for, or I don't know, filing purposes or something like that. Okay, how do we do that? Well, we want some sort of a chunk of last name, and the way to do that is using a function called write. And write is like left, except it's the right side, it's the opposite side. So I'll demonstrate. So I'll go right. Let's say, we'll get the first character on the right. Part last name, comma. Okay. And as you can see, it's taken the E on the end of Veldy there and put it on its own. O on the end of Aleo, put it there. Now that's not quite what we want. We want the whole thing. Now in the case of Veldy, that's 1, 2, 3, 4, 5 characters. So we want in the case of Veldy, we want the right 5. Great. But that's not worked for this one here because the last chunk there is actually 1, 2, it's 6 characters long. So how do we code in a sort of a variable style to get a big chunk where that chunk, the size of that chunk, varies according to the data on that particular record? Well, here's how we do it. Okay, there is another function called car index. So let's get stuck into car index. Now, to find out about a piece of SQL, there's two ways to do it. You can look up the online help or the local help for SQL Server, or alternatively we can just Google it. So you know what, let's just go to Google the darn thing, and I'll show you what to search for. We'll search for SQL Server car index. Okay, and that has taken us to, you know what, I will take you to the official Microsoft documentation website and the page about car index. Now, this looks a bit technical, but I really would recommend that you attempt searching for these commands online, especially the official documentation for Microsoft, because you do learn a lot, and it is the primary authoritative source of information about SQL. It may look a little bit scary, but the more you get into it, the more comfortable you are with it, and the more you're going to learn. So let's just look a little bit at car index. Now, what does car index do? Syntax. Okay, syntax is basically the way you write a piece of code, the way you're supposed to write it. So, okay, what is it telling us? Car index. This is basically the way Microsoft are telling us to write it. That's the function name, starts and ends with a bracket, as they do, and these are the parameters that it accepts. First is the expression to find, what we're looking for. The second is expression to search, what we are actually searching. We're looking for that and we're searching in that. And optionally, we can have a start location. That's what these square brackets mean. means it's saying that this particular parameter is optional. You don't have to put it in. Now, what do all these things mean? Well, it actually explains it down here. Expression to find. Expression to find a character expression containing the sequence to find. And it goes on about the fact that it's got an 8,000 limit, but that's what I explained. The second parameter, expression to search. That's explained down here. Expression to search, a character expression to search. So it spells it all out for you. And just on this last one here, start location, an integer or big int expression, in other words, a number, at which the search starts. If start location is not specified, has a negative value or otherwise a zero value, the search starts at the beginning of the expression to search. So in other words, if you don't put in that last number, it just starts searching the piece of text right from the beginning. And if you put in like a 3 or something, then it starts searching from character 3. So enough learning about it, let's actually do it. Okay, so let's say we are interested in the first instance of a space. The first instance of space in the last name. So that's what we want to find, because we want to sort of delineate, we want to find the second chunk. So let's just find it. Okay. Car index. Open brackets. Now what was the first? Okay, the expression to find. What are we looking for? Well, we're looking for a space. So single quote, space, single quote. It's a piece of text. Pieces of text have to be surrounded with single quotes. Comma. What is the second one? The expression to search. Well, what are we searching? We're searching last name. And the third parameter, well, that's actually optional. We know it's optional because it's surrounded by square brackets. And the help actually says if you leave it off, it's just going to start at the beginning. So we'll just leave it off. And give it an expression. Where is the space? Okay. Right, that's given us a 6. So out of that last name there, you know what? I'll get rid of that part last name there, because that's kind of confusing us. So where is the space? That is returning a 6, which is telling us that the first space is the 6th character in Van die Velde. So let's just count it off. 1, V is the 1, 2, 3, 4, 5, and 6. Hey presto, it's there. Right. So 9, if you actually count those characters there, you can find that the space again is the 9th. Okay, wonderful. So basically what we want to do is we want to use that piece of information to find out how we can get the second chunk. This is how we do it. Now this is a little bit tricky, but basically it involves getting the entire length of that last name, the string that we're searching. Now the way to get the length is another function I'll show you called len. And that takes an expression, in this case last name, and we'll call that, okay. That is the length. If we actually count Van die Velde, 1, 2, 3, 4, 5, 6, the E is the 11th character, and there you go, it's worked. So how does that help us? Well, what we want is, we want the right chunk. We don't want all of it. We only want that up to the first space. So I think you can see where I'm going here. We can calculate the number of letters up until the first space there by going length minus the position of the first space. So what we want is, in the case of Van die Velde, we want the leftmost 5 characters. It's right, let me see now, it's 11, 11 minus 6 is 1, 2, 3, 4, 5, 11 minus 6 is 5. Hey presto. Out of this guy here, we want the actual 1, 2, 3, 4, 5 again. 14 minus 9 is 5. So you can probably guess where I'm going with this. We're after the number of characters being the length minus that length, which is the length from there to the first character. So total length minus that is the number of characters that the last chunk of text occupies. So to actually get that number, this is how we do it. We're going to do an arithmetical operation. I'll call that expression as the difference. Now, as we saw in an earlier lesson, we can take numeric values and perform operations with them using your basic arithmetical operators, plus, minus, asterisk meaning multiply, and so on and so forth. Now, so far we've been doing it with columns, but we can do it with expressions, and that's exactly what we've done here. So we've taken that expression, which in this case will be 11, and that car index being the first space, which is 6, and that minus that will result in a dynamically calculated amount. So 11 minus 6 is 5. In this case, 11 minus 9 is 5. 17 minus 8 is 9. So let's use this calculated expression in our right function. And you can see what I'm trying to do. We're trying to get right that value there. So let's just do it. Okay, right, last name, and that sort of difference amount there, and let's see what the result is. Okay, what have we got? Valdi, that's the rightmost chunk of the last name there. Aleo, Demeteos, Chandakat, I can't pronounce that, but you get the point. So what we've demonstrated here is a fairly powerful technique in getting chunks of text, breaking up text, parsing text in SQL Server using arithmetical operations and the right and left functions. So let's recap the functions, the text functions that we've covered in this lesson. The right function, which takes a piece of text, a number, and gets that number of characters on the right side of the string. Car index, which will find for us the first instance in terms of the number of characters along the string of a particular string within another string. So this is what we tell it to find, this is what we tell it to search. Optionally, we can start not necessarily at the beginning, but anywhere along the string, and that will return the first point in the string in terms of a number where this is found in this. And then of course there's len, which returns simply the length of the string.